the VM environment, and I was like, oh, I'll just recreate it, no problem. But either way, I do have it. I basically have it done. It's just the syntax. There's some quirk with TFTP server that doesn't want to serve the file correctly, but that's fine. We can continue on anyways. I think we'll be fine.
Okay.
We still get to run commands. So
I don't think quite everyone was here last week. Would you be able to give the Spark Notes version of sort of the process and where you're at, where we left off on last week?
Yeah, 5-minute breakdown of what you did, right? A little bit of the process and where we left off.
Gotcha. Okay. Yeah, let me share out my screen here, and I will do just that. I'm going to minimize some of these windows here. We'll open them up when we're a little more ready for them. Okay. So, can you? I'm going to get rid of all these. Okay. Let's see, share a screen. Screen share. Cool. All right. So, can you see the screen pretty well?
Yep, looks good.
Can you see the right screen is the question. Looks like it's got Packet Capture XOS.
Yeah. Yep.
Awesome. Okay. So basically, take you from start to end here. This is an XOS operating system that's running on a Calyx router. It is currently running on a GigaSpire U4, which is a router that is actually the standard for deployment for a local ISP known as Shawnee Link. Shawnee Link provides gigabit internet. It's great. Rural town, terrible internet, but they brought in fiber and they brought these modems with them, modem router combos really, and couldn't be happier with the internet service, but the router is not so great. So by default, we do have a login. It is, I believe, just the admin account here. I don't have the password off the top of my head, so we'll just use the one we hacked into last week. Basically, when you log in, the support and the beta features tabs are not available to you, but they are simply disabled with an HTML comment. So you can actually modify the response, remove the comment, and you'll get this back. From here in this section, you have some interesting tools. You have some TR069 settings. You've got some WAN uplink settings. You've also got some interesting things like packet captures. You also have some logs here, and you've also got some configuration things. You got a whole bunch of stuff that you're not normally supposed to be able to see. This is only intended for the support users. Now, if you go into device logs, we found out last week you can actually download a log. If we do this here, it'll take a couple seconds. It'll generate. It actually dumps the entire contents of the temp. I believe it's temp log is the folder that it's ripping out of. And inside that file, inside that tar file, there's a bunch of interesting log files, some of which, if I can get my file manager to open it, some of which include, let's see, var log, and then HTTP CGI. HTTP CGI is an interesting file. It has a bunch of, whoa, jumping a little bit ahead there. Those are command executions. Okay, let me grab the previous of this. So basically, inside this file, there's a bunch of stuff. Specifically, there is HTTP CGI log, which should contain, if I'm not mistaken, nope, we need one more. Should contain, yeah, here we go. So it actually contains stars in the original version, but what you can do is if you can cause the system to do a panic, what it normally does in the log files is it redacts the passwords that are in those files. It actually replaces them all with star, but if you can cause a panic, it'll actually tar all of the log files, and it'll leave them in the temp folder. So if you can do that, and then you request a log file again download, it will actually dump the credentials for all of these different accounts that have tried to log in. So now this is the actual password for the admin account, Guide China Very 1992. There's also, we were able to manipulate the authorization. We can see we get some weird MD5 failures. If you try to manipulate the token, you can actually get it to spit out the expected password for other user accounts. I don't think I have it. Maybe I don't know if I have it in this one, but basically, if you dig around through these log files, you'll find there's config file. The config file has another user that's created called supervisor. Supervisor is a support user, doesn't have any different privileges besides that section. We can just disable, the HTML comment and get it back. If you try to supply a token and you modify that token to say, yeah, I'm the support user, it will actually throw the password that it expects in here as well. So that's how we get that account. So we've got an admin account and we've got the supervisor account. Still don't have access to the system though. That's kind of where we left off last week. There was a little extra that I actually did, I think at the very end, where we talked about doing different kinds of command injections. And we did get a little bit of command injection, but we didn't get any system access yet. The way we were able to do that is I don't remember the gadget I was using last week, but in this example, I was using packet capture. So packet capture, what we can do with this, let me grab a request here. There we go. So this is what packet capture normally looks like. We had a really interesting gadget where, it allows you to, work on these different interfaces. But on one of these hold on, let's open this up in Visual Studio Code. So if we actually look at the network connections, because it dumps literally all of this information from the system, you can see that there is a bunch of internal services that are listening on the loopback adapter, but they don't actually give you any access to the LAN or the WAN. You can't access these services normally. These are internal management services that function as basically a TCP wrapper for a command line for these interfaces, for these different administration or different management consoles. What we could do, because they're all on the loopback adapter, is we can actually specify in our packet capture the loopback adapter interface, and it will actually start capturing packets. And because it's all unencrypted, because it's on the loopback interface, we can actually see the entirety of all the commands that are being executed on the system, at least in between the processes as it runs. Now, in doing that, what we found was, if we start a packet capture here, well, actually, I won't start that. I already got one here. If we open it up here, these are some of the ones that we've got going on here. We can actually, I believe, can I grab it? Yeah, okay. This is the TCP stream. We can see that in the response here, we captured this request. It actually dumps the passwords again. Support 1's the supervisor password. You can see the red is the send TCP data. The blue is the receive. And as you can see, we're jumping a little bit ahead in this regard. But basically where we left off was we had command execution here where we could kind of inject into it. We didn't have a command to be able to get root access yet. So that's the preface. I know that's fast. It was an hour to go through last week. I hope everyone's kind of on the same page. I will take any questions to get up to speed if you're willing.
That was the best cybersecurity elevator pitch I've ever heard in my entire life.
It was a little compressed. I think, yeah, basically we've taken over supervisor account. We had the admin account. We've taken over the supervisor account. We didn't get any extra access with that because we already had broken access control for the admin account. So the only thing that we have now is access to these device logs where we can download this information about the device. And we have found out that we could potentially inject commands by modifying, for instance, injecting some additional command parameters. The command line operations, I can probably pull it from this. The command operations normally run, and they look something like this: exec pcap start, and then they pass parameters in with these little brackets. So potentially you can see these are some of the previous attempts. We tried to do like, ARP and cat etc, but it actually trimmed shadow off the end there because the command can't be that long. There were different command injection attempts, but the nice part is now that we had this last week where we could follow the TCP stream, we can actually see the response code and for these different commands. So not response code, but the response data for these different commands. So whereas before we would inject and we'd have some form of blind injection where it would say, it just failed. Now that we can actually capture the traffic on the loopback adapter, we can say, oh, well, this one ran and this command part of it failed. What was it expecting? And from there, we can craft an exploit. Whenever you have insight into a system that you're attempting to attack and break into, whenever you can get insight on what the backend is doing on that, you get it makes it a lot easier to craft something specific for that. For instance, if you were to analyze these commands a little bit here in the hex format, let's do hex dump, you would notice. So I was trying originally, you'll see that I was trying originally to do like, you know, and cat etc. That's not going to work. This is a simple application. This is a simple management interface console that it's communicating with here. It doesn't expect anything crazy like that. Doesn't have advanced bash syntax. So you can't do and, can't do or, can't do semicolon, doesn't accept any of that. What you have to do, if you look at this, you have to pass a 0A, which is a new line character. That indicates that it's the end of the command and the next command is starting. And because it's on a raw TCP socket, doesn't matter if you send more than one command at once, it'll just take it and process it as it comes. So anyways, like I said, I think everybody's mostly on the same page, hopefully. Anybody lost with that? Okay, I think we might be good.
Yeah, go right ahead.
Awesome. Okay, so where we left off, yeah, we had some access to this here. If we went in and we were to do a packet capture against this, I'm trying to think, what did we use last time? There was an interface we used last time. There was a gadget. I'd like to go through that if I could. I believe it was the log. I believe it was log. I believe it was steer log. We were trying to download steer log. There is a command for each one of these different things. So this just downloads it. If we grab burp here, here's what I'll do. Let's grab burp. Let's look at that log dump command. We can see that we issued a log dump context for steer log txt. So we've got this log name here. What we might try to do to break out of it, like earlier, was and cat. We know that's not going to work though. So what we can do is we should just analyze this on the back end, right? Logically speaking, we should analyze what this is actually doing with our packet capture and see where that goes. So let's do that. I've got the commands queued up for the loopback adapter. We'll start from scratch here again. We'll do this, and we'll say file size 10, start and stop. And now we have those two commands in our proxy. So we've got, let's see, we've got a capture command here, and we've got our stop command here. So what we'll do, we'll get those formatted. We'll make this the loopback adapter so we can capture it. Final command, we've tested this, doesn't do anything. So we'll start the loopback capture. We'll go back here and we'll run the steer log, and then we will stop the capture and we will download the capture. Let's open it up here and take a look at what it's doing. Minimize all this. And we've got a PCAP capture. Let me close out of this replace. Cool. So we know that the file name that we gave was steer log. So let's look for a frame that contains steer log. And we have some. Let's right click follow and see what it's doing. So we see that we have this xget log get content log name steer log. So logically speaking, if it's working through it in the sense that each command is its own little thing and they've got a new line at the end of it, then theoretically, what happens if we were to inject a new line into this and try to break out and run a different command? Let's do that. Let's just try that. So let's go back here. We will start this over again, go back to steer log. And we know the syntax is going to expect it to be something like, single quote, bracket. So how do we inject a new line into JSON payloads? Easy. We do JSON Unicode encoding. So we'll do U or /U 000A. When you're doing, this is a really good trick for bypassing WAFs as well. If you have some sort of basic filtering going on WAF level, or if you need to encode some data quickly and it's a restricted character or something like that, what you can actually do is you can URL encode the character. So for instance, we'll do, so we're trying to do a new line character. In this case, we're not going to do it. We already know it's 0A, but let's say we're trying to get quotes past the firewall and the firewall is capturing quotes. What we can actually do, we can select the quote character, convert selection URL encode, we get 22, and we just replace the % with U00, and it's 22. The reason why is because it's a UTF-8 character, so it is expecting, or UTF-16 character, I believe. So it's expecting 2 bytes. We just give 00 at the start. That's just nothing. And then 22 is the second half of that byte there. So easy conversion. Now we've got U00A. We have a new line injected. So let's just, let's go back to our capture, run that, see what happens. So we start our Oracle, kick this on, stop the capture, and we'll download this log file again. I'm going to always open it with WinZip. And let's exit this out. Open this. It's a little bit of a manual process, but it's much better than downloading the log file and waiting 30 seconds every time. We've definitely improved that part of it. So we know steer log is the frame we're looking for. Start this up, follow TCP stream, and we can see, where is this? Right here, steer log. We've successfully injected our single quote bracket, and we started a new line, and we'll see it says command, which is this, which is just this here, not found. So we know it's trying to execute that command. Obviously, that's not going to work because this is not a valid command. So let's look at valid commands. Well, we know that the command it's running is log get content. So let's go back here. Let's go to log proxy, and I will plug the wonderful secret searcher tool that is available, github.com/govango. And let's go ahead and run it against log get content because we know we're looking for log get content. I don't think this will be a problem. We'll do that because this is, I believe, regex is what's going to try and interpret. And we already see we got some matches in LMD info. So let's open up LMD info and let's search for our log get content. So we see this is the configuration file. What we just searched in, by the way, I don't think I was clear. This log proxy folder, this is the dump of all of the system from the support level user. It includes all of the configurations as well. So this LMD info file, as context, I've went through and researched it. If you didn't know, you would just search for this, see if you can find anything interesting maybe. This is the configuration file for the actual command syntax. So we can see that log get content expects a log name parameter, a current path, row number, but we're not necessarily in this for log get content. We want to run other commands. So what we have to do is we have to find a gadget now. So we know these are our commands that we could potentially run. We have to find some kind of gadget that gets us access to the system. Now, you scroll around, you can look around for a little bit, but I will cheat a little bit because I've been through all these. I know which one's available. There is one very interesting command known as tftp file. This is not to be confused with FTP or any sort of SFTP. This is a trivial FTP is what it's called. It is a very simple syntax, doesn't support nearly as much as FTP or SFTP, and it's kind of a corner case. In this case, it's used in the system mostly because of its lack of complexity. Because this is an embedded system, they need to optimize on space and performance, and this is a dirt simple transfer command for files. So this is our command syntax. We know what it is. It expects a source, primary server, primary file, local file, and it looks like this is an optional parameter maybe. It just says option, so we'll try to leave those off for now. So obviously we're not going to run xexec. We don't have that sort of privilege from the command that we're running. If we examine our log file, we'll see that most of these commands are getting called through xget and then /xexec. So we'll copy this syntax. We'll say, okay, well, we want to run tftp file. So we'll go back here. We'll go to our steer log file, and we'll get rid of steer log because we don't really need steer log anymore. We'll close out the command u0008, and we've got our xget log get content. We don't want log get content though. We want tftp file. We are going to look at the parameters that it requires now so we can fit this in. It expects a source. So source, I assume, is probably going to be the directory that it fetches the file from on the remote server. Primary server, this is going to be where the file is actually hosted. I'm going to give my local computer's IP address. Primary file, I assume that's the one it's going to be fetching. So we'll say hello txt because that's what's set up. And we'll say, we'll say the local file. This is probably where it's going to put the file. We're going to say etc, well, we'll say etc xxx for now. And I don't believe these other commands are necessary. So with that being said, let's start our capture, go back, start it again, and stop it. Now we've run that command. Let's download it, see what it does. We've got our packet capture here. We'll close out Wireshark, transfer our packet capture file back. Let's check out what's going on with it. We can see very simply that, well, actually, no, we didn't have steer log now. So we did etc. So let's do etc. Does it not run? That should have caught it. That should have caught it. Actually, no, I know what's happened. This is the problem I was running into. There we go. So we'll notice that we do actually get the log get content, and we try to exec TFTP file, but you'll see two things. First off, we cut off at primary sir, and then we have this. So what's happened in this case, right? We've developed a payload, we have command execution, but at this point we're playing code golf, and there's no way in this circumstance to be able to get code golf to fit into that small space. So what's essentially happened is it said, oh, the parameter for the log file name can be no bigger than this many characters. And it trims us off right at the end. So we don't actually get to inject our full command. And then the leftover, this part here is the leftover of the log get content getting appended to the end. So this is not going to work. This gadget's not going to work. So we have to find a different one. Luckily for us, packet capture. Packet capture functionality in itself has a fun little advanced expression box, which by nature allows you to do advanced filtering on the packet capture. It allows special characters, and it also has an arbitrary size limit. So this is a perfect gadget to get around our restriction. We have arbitrary input size, and we have special characters being allowed in this input field. So let's submit a little something and start it. Start failed. Okay, that's fine. All we need is we need to check the parameters that are sent. So we see this is our advance command here. So let's send this to repeater. We'll go into repeater. We'll send it. It's going to fail. There we go. Cool. So I'm going to start on loopback just for the fun of it. And we already know kind of what's going on, but you know, let's check it out. We'll check it out. There's no problem with checking it out. We'll start the capture. We'll try to run it again. It'll fail. We'll stop the capture. We'll download the capture, open it up, and do the same process again. So we'll get rid of Wireshark, copy this back here, place file. Very cool. Open this up. Okay, that doesn't matter. Frame contains, let's see, what was it we were doing? I don't remember what we put in that content there. This should be fine. Cool. So let's follow the conversation. We see that we get exec packet capture protocol IP expression, right? So this is where we're at with it right now. So, and obviously this expression is not going to be valid, so it's going to fail. So we kind of have an idea of where we're at in the expression. We're at the very end, which is perfect. Not that it matters, because we can just make the commands above and below become invalid, and it'll still run our command in the middle. We'll sandwich it kind of. So what we'll do is we'll take our original payload, which is right here, log dump content. We'll take our original payload. We'll put this back like that. And we will notice as well, just to be double safe here, it looks like that it actually ends it with a double quote on that. So actually, wait, are all these double quote? Maybe that's why I was having trouble earlier. Yeah, all these are double quote. Okay, well, let's do this then. That's probably where my problem's coming from. So let me grab this. I'm going to format this really quick here. We're going to grab all of the single quotes. We are just going to make these double quotes. And actually, you know what? We're going to make them double quotes, and because it's going in JSON, we're backslashing them. Okay, cool. So we're going to use this to escape our command here. We are then going to, we're going to need to run this command. Now, because it's going to try and append the rest of the command we're injecting into at the end, it's not going to run. And we could try to do some fancy schmancy craft it to make it work at the end and make it a valid parameter. That's too much. Instead, very simply, U000A, we're going to do a new line, and we don't have to worry about whatever's trailing on the end. It'll just try to run on the next command. It'll fail. Doesn't matter. So we'll start our packet capture again. Go back over here, run this, and stop. And we will see what it actually does. If we download this one more time here and go back, let's kill, yeah, we've got Wireshark killed, cool. And we know that we are sending it to, I believe XXX or maybe ZZZZ. I don't remember what I put on here. That's okay, we'll just do PCAP and that should pick it up, yep. And we see that we do have, okay, we do have exec TFTP file, and it looks like it's looking fine. Now, this is normally going to fail. The reason why it's not failing is because I've done a little cheating and I've got it set up. So let's switch gears a little bit and let's talk about something else. Let's talk about the fun of debugging. So let's see. Give me 1 second. I'm just going to grab this command. Okay. So this is my local system. This is not the virtual box that we're on right now. If you were to look around, so we have our gadget, we have command execution. We technically did, but let's imagine that we didn't have a server running yet. We need to get a server going. Okay, cool. So we download, we look online, we say, hey, what's a simple server to get going for TFTPD? There's a Python implementation. So Python implementation, let's see, Python implementation, PTFTPD. We run that, we get some commands. Okay, cool. So let's do verbose, and it wants an interface. Now here's where it comes into problems. TFTPD is not meant to be a Windows program. It is meant to be a Linux program. It's meant to be a Unix system program. So the interface, where it would normally be F0, is going to be some god-awful UUID in Windows. Unfortunately, we have to go in and we actually have to debug some of this code here. I've gone ahead and cheated. In this case, this is a prime example of why knowing a little bit of programming is really great. If you run into any problems with your tools, you can hot patch them, you can fix them potentially. In all honesty, I'm very tempted to push this back to TFTPD's repo, and I probably will when I get a little bit of time. But what we're doing here is we're going to print out the interfaces on Windows. It looks like what it's using is it's using the interface name just to get the IP address, which is really dumb because it should just ask for an IP address if that's what it wants. But what we'll do, we've got it printing out the interfaces and the names. We'll do XXX because we don't know what the interface is. Whoops. Well, actually, let's do this. Let's do PTFTPD VXXX, and it wants, according to syntax, it wants a root directory. We're just going to serve out of the local folder, so we'll do dot. And okay, unknown error, unknown interface. But we have all these IP addresses now. So the one we're looking for, some of these are virtual. The one that we're looking for is this one. This is our LAN address. And this is going to be the interface name because we have it printing out the interface and then the interface addresses. So this is our interface name that we want to use. So we'll do PT, FTPD, verbose with this. And to save on a little bit of the noise, I'm going to comment that out so we don't hit that again. Whoops. There we go. Perfect. This file, by the way, this is out of the site packages. So I'm using pipenv, which makes a virtual environment for Python. Ran pipenv, installed the package I needed in a virtual environment as to not cloud up my system. Went in to the virtual lens folder under your user directory, went to the new folder directory, which is the environment. It names it after the folder that you're running pipenv out of. Went to site packages, found pftplib, and went to the FTP server file to actually look through and see what it's wanting, hot patched it, and there we go. That's just some context for that. So we know what it wants. Let's run that. And sure enough, we've got it listening on the correct address on the correct interface. So if we go back here, and also in this folder, we have this hello.txt file. So we have a TFTP server, or we have a TFTP server. We have command execution to download files. Now, the thing about it is this system, this Calyx system, this is a very insecure system, because it has a very wide attack surface in the sense that everything runs as root on this system. So normally, if you've ever done anything as far as setting up a server or related, you'll often find, even something as simple as Minecraft, you'll often see that their recommendation is to create a user for the Minecraft service. Well, the reason being is that if the Minecraft service ever gets compromised and you're running that service as root, whatever compromised that service is now root on your system. And, you may think, oh, well, they don't have a bash shell. They're not logging in with SSH. What can they do? They can only, in this case, they can only upload files. Well, if Calyx had done it correctly and they had restricted each service to its own user account, I wouldn't be able to currently replace the etc shadow file, which is what we're going to do. So etc shadow, if you're not familiar, is the password file for Linux. etc shadow contains all of the actual passwords per user account. And what we're going to do here, we know from last time that there's actually an SSH server that's open, and we can expose that SSH server by using some tricky port forwarding rules. It normally blocks it on the LAN interface, but if we port forward from the WAN interface to that local router address with the port number of the SSH server, we can bypass the IP tables rules and we can connect into SSH, but we still don't know the password or anything. So what we're going to do, we know that it's root because some of the config files say that it enables root access in the etc drop bear configuration. So we know username's root. We need to get a password. We're going to replace etc shadow put our own password in there, try to log into the system. So let's look at etc shadow. First, we need to understand probably what etc shadow actually is. So we'll say syntax for etc shadow. And we'll look at this. Oh, it's going to check if I'm an actual bot. Okay. Oh no, don't make me. Oh no, it's going to make me do a captcha. I got to pick the boats now. There we go. Okay, cool. So we're going to look at the format of etc shadow. So etc shadow is a file that contains a bunch of entries, and they all look like this. According to this format, we can see that it's all separated by semicolons. We can see the first one is going to be the username for the account. Second one is going to be the encrypted password in a hash format. Third is going to be the last password change. Fourth is going to be the minimum days, between password changes. 5 is maximum days, after which it's valid. Warn is the number of days. All of these, quite frankly, they don't matter for our purposes. What we're going to do is we're basically going to capture all of this. The last password, last change, that doesn't matter. We can substitute it with their value. What we really want out of this system is we want to be able to get this hash here. So we want to generate an etc shadow hash. So how to generate etc shadow hash. And this system, I will give you some advanced knowledge. Tried to do SHA-1 or SHA-512 or whatever they have for the password file. Doesn't work. This system is very minimal, and so it only accepts MD5. So as a recommendation going forward for me to you, if you have a system and you can replace etc shadow, just go with MD5 because it's accepted everywhere and it's short and simple and easy, and why not? So we'll look at some commands here. We got one method. This is the one that I actually used. This one you can accept MD5, SHA-256, SHA-512. This is a Linux command. So this is a Windows system. So there's some problems with that. mkpassword's not available for Windows, at least not easily from what I've seen. So there's a bit of a problem there. I was actually fortunate enough to have a Linux system that I was able to use to actually run the command. If you are unfortunate and you are stricken with lack of Linux VMs, as I am not, there is actually hope. You're not in the dark. You can download Ruby, and there is a wonderful, as much as I despise as a Python developer to recommend Ruby, there is this Unix crypt module which appears to generate the hashes exactly as you need for MD5. So you're not completely lost. Just download Ruby, jump through some hoops, gem bundle install. It'll be fine.
Python guy recommending Ruby. Shit, I love it. This is awesome.
So what we'll do, I'll cheat a little bit because I've already gone through and done this. Let's see. I don't believe I can pop this out. Maybe full screen. That did not do what I wanted it to do, and now I'm stuck in full screen. Okay, we'll cheat a little bit here. We will say, cool. Okay, let's do this. So this is a Linux remote console that I have access to. Don't worry about it. It is my system. There are no concerns with its security, I promise. We are going to generate a password using this. We'll say, let me in 123. And we get a nice hash there. Couldn't be simpler than that. So we're going to grab this hash. We are going to take it over to our password file, which we have not created yet. Actually, I think we have on this system. Let's see. Do I have it? Yes, I do. Okay. So we're going to take this file here. Username, password hash, and then a bunch of information that's not relevant to us. VM is confusing me here. Yeah, here we go. So we'll do username, and then we'll replace it with our password hash that we generated, and we will save that. And so now the password hash should be let me in 123. So this is basically what an etc shadow file is. Normally you'll see it with other users, so it'll be like admin, and then I think www has an account. None of these will have passwords, so they'll mostly look like this. But this is what a typical etc shadow file looks like. So we'll save it with our root, and then what we'll do is we'll go back to our server here. We are currently serving requests to this IP address. So, and this is our file. So we've got our file all set up and everything. Hello TXT. So what we will do now that we have all of this done, we'll go back here, go to burp. We will go to capture start, and then we will run our little command here to grab hello txt. And we're going to save it at etc xxx. In this case, I believe I can save it to shadow. If I nuke my access to the system, I will be sad, but ultimately not the end of the world. So let us do that. We're going to stop the capture, and we're going to check out and see how that command ran. Make sure that it did actually execute successfully. Let me see this real quick. Let's see. We'll go here. I'm losing my train of thought here. Grab this. Replace. Packet capture. And then we're looking for frame contained shadow. If we open this file here, we can actually see, yep, we can see etc shadow, and it looks like success. Looks like we have replaced access to the etc shadow file with our false hello txt. And if we go back here and we look, we can see client requested non-existent file hello txt. So TFTP, I believe, is bugging out right now. I don't believe that that's going to give me access, and I believe I may have nuked access of my own to the system until I can get that file to resolve there. We'll test it and see. I don't exactly remember. I've cheated a little bit. I've opened it up to the local system beforehand. We'll pretend that I switched networks and we switched over to LAN, or from LAN to WAN, and we are now accessing it from the external address to the port forward that is going to redirect it to the drop air system. So we're going to do this. We can see that we have a login as. We're going to do root because we know username's root. This is a banner, by the way. I replaced the banner while I was testing. So just ignore that for the time being. We're going to grab XOS. So first things I'm going to do, I'm going to try let me in 1, 2, 3. Access denied. Okay, that didn't take. I think I may have nuked access to the system. Okay, no, that let me in. Okay, so the syntax of the command was slightly wrong when I submitted this over here. Like I said, I killed the VM, so I don't remember the exact syntax, but this was the command that was done. There is some quirk with TFTPD where it doesn't want to serve the file correctly. So this is a whole debugging thing in its own. Don't have a whole lot of time to do that tonight, but let's pretend that it did work as intended and this library wasn't not great and modular. And it actually did serve the hello txt file, which obviously it did because I have access to it now. We have access to the XOS console. From the XOS console, you have complete system access. You can see that you are the root user. The reason why you are able to get in is because everything runs as root again. So if we look at our inspection here, we can see, this is only accessible, readable, and writable from root. So because it ran as root for the system service, and because we exploited the system service, we can modify files. We modified a file that was owned by root. If it was under another user account, wouldn't have happened, wouldn't have been able to happen, which is a great example of why you should probably segment all of your different services with different user accounts. So we have, we basically have, we really do have root access at this point. You can do anything you want on the system. There are some interesting things that were on this by default. There was for instance, a Chinese antivirus, Lionix Lionix Rapid, which is kind of sketchy. It is a interesting exe, but I can look at that in a minute here. I think I'll open it up if anybody has any questions on how we got this far or any comments so far. I think this is a good midway point. No, nobody? Oh, cool. All right. Hopefully I'm not going a little too fast here. I know if you weren't here last week, this is a lot to go through at once. So let's do this. Let's take a look at see if Rapid's running. Rapid's not running. Okay, I killed it previously because I was in here, but we can see from the / directory. Let me go back up here, OSAL. We can see a bunch of information about the system. We can also see the disk layout. We can see how everything's mounted. What I would recommend if you are going to do analysis of a system that has potential for update or breaking or anything of that nature or variety, I would recommend dumping this file system. Easiest way to do it is to just tar everything and throw it somewhere. In my case, we can see that, file system's pretty big on some of this stuff. We've got quite a bit of data, 259 under, well, actually, no, used is not a whole lot. It's 321, 3.5. What I would do, because tempfs is going to be our biggest folder, this is actually just RAM, basically. What we can do, we can just tar everything, throw it in a /temp folder, or /temp/ I don't know, rom.tar or something, and you've got the backup of the entire system. So if you end up blowing it up, or if you end up that it updates automatically or something crazy like that, because, hey, auto update, that's the thing these days. If it ends up doing anything like that, you can always go back and reference all of the applications if you lose access to it, or if you accidentally brick your system again, you can go back and, hopefully undo what you've done, unbrick it without having to get to the chip. Yes.
Yeah, hey, sorry to interrupt. I don't know how Linux this OS is, but if you throw it into temp and you have to reboot it or something, won't that blow it away? The backup?
It will. So you do have to, exactly. So you do have to grab it. So when I said that, yes, do that, but also transfer it to your local system. So originally I had a little bit of a minor stroke when I was first doing this. Also, I think it was like 12 a.m. So that might have been the other part of it. But basically I was like, how am I going to get this thing off the local system, right? I thought, oh, well, they got TFTP on here. I'll do TFTP back and send it. That's ridiculous. This is a drop bear server. It's an SSH server. SSH servers by default have something called SCP. So what you can actually do is you can open up SCP here, and we will go to 10.0.0.1. We'll open it up for SCP. We'll do 3007 because that's the port. We'll do root. Let me grab my master password here for it. Paste that in, and we have file transfer access. And because we're logged in as root, we can go anywhere and we can transfer anything. I wouldn't recommend transferring all the files like this if possible, because it's gonna dog with overhead for all the SCP files. It's just gonna be a nightmare. You'd be better off throwing everything into a tar folder. As tempting as it is, or I'm sorry, a tar file, not a folder. As tempting as it is to Control A and then click and drag, it's not gonna work out for you in the long run. But yeah, no, you're absolutely right. If it's thrown in tempfs, with it being in RAM, as soon as the system dies, you're gonna lose that. So throw it in tempfs. Grab a copy down to your local system. Gives you a little bit to work through as well. And we're gonna do a little bit of that. So now that we do have a little bit of this, we can maybe grab Rapid 7. Hopefully that answers your question. Yeah.
Yeah, totally. Thank you.
Awesome. So let's go through and look a little bit here. I'm trying to remember where it was. I believe, you know what? Actually, I believe it's a hidden folder. Yeah,
You said
I believe it's a hidden.
Rapid 7 accidentally, but you meant to just say Rapid, right? There's this,
Rapid, yes, not Rapid 7. I got Rapid 7 in my head. I don't know.
And you know what's really funny? As an ex-Rapid 7 employee, you keep raising eyebrows every time you say that. I'm like, what?
we're gonna hack into Rapid 7 right now.
It's like I didn't deploy any fucking malware to this fucking router. I swear to God.
I saw. Yeah, no, that's my bad. You're right. So a really useful command you can do on Linux is find. By the way, so you did say how Linux is this system. LSCP is not installed. Of course it's not. This system is actually, it is, you can find this out from the exe. I'll show you in a minute how we found this out. But it is actually an ARM32 microcontroller or microprocessor that is actually running everything. So these are all custom compiled for ARM32, which is unfortunate. It makes sense as to why, because it's a embedded device, so it's going to use something that's not a full-blown x86 chip. But it's also a little unfortunate because it means that if you want to move any applications to it, you have to compile them for ARM32, or you have to write them in Go, which is honestly my recommendation at the moment. I haven't worked with ARM32 hacking in a whole lot of detail, but that being said, Go is super easy to cross compile. I've had no problem with Go. I think Shane recommended, what was it? Starts with a C and it's got like a badger for its icon. You know what I'm talking about, Christian?
No, I don't,
It's
unfortunately.
Cosmopolitan. Cosmopolitan.
Yeah.
That was it, Cosmopolitan. There's a C library you can use that's called Cosmopolitan. Personally, I would just recommend Go for anything that you would want to develop on these systems, just because it compiles so easily. Alternatively, if you really wanted to get into it, you could do an ARM32. I'm not as into ARM32 architecture on that scale. So if I did anything, I would just do it in Go and then cross compile it.
And just for everyone else's reference, if anyone's worked with a Raspberry Pi that's 4 gigabytes or less, right? It's the same architecture as the Raspberry Pis, basically, right?
Oh, I didn't realize that.
Oh yeah, yeah. So basically, anything that you convention like, and I mean, this certainly does not have enough RAM or resources or anything like that. But they have Kali Linux for ARM32 and all that. It is wow, okay, but it does work. We actually deployed Raspberry Pis back in the day for pen testing. Travis
it sucked. It was terrible.
I would almost wonder if I could rip off those executables out of the I probably could just rip them out of the system, moving them over to this thing and have them run. Since it's the same architecture, should be fine.
You just need to make sure you get the necessary dependencies and whatnot. Do you happen to know what distro this is based on? Are we talking like, is it like a DDWRT or UC Linux?
Yes. So that's a good note. There is actually in some of these log files, I don't remember which ones. I can maybe find. I believe it's OpenWRT. Well, besides those name servers, there are actually log files that specify. The realm is open. Whoops. That was a hiccup on my Hyper-V machine. Sorry about that. If you actually look at these, there we go. If you actually look at these different outputs from Secret Searcher, you'll see some of these actually output OpenWRT. So my assumption is that this is an OpenWRT system. Maybe not. I'm not familiar with the internals of OpenWRT enough to say, but that's what I'm leaning towards.
Yeah, like 90% of consumer grade, like router, modem, WAP combos are running OpenWRT or some variant of it and that kind of stuff. That makes a lot of sense. That's good to know. Cool.
Sure. So what I was going to say is one of the interesting commands, or one of the great commands that you can actually use on Linux systems is find. If you do find / name, you can actually specify. You obviously put wildcards around it. You can specify any file name, and it'll look for it with any sort of matching. So in this case, I know we're looking for Lionic, or we're really looking for Rapid, not Rapid 7. If we search for Rapid under the root directory, we can actually see that we do get some hidden folders here. We get a rapid.db file. It also looks like we do have some user sbin or user local Lionic user bin Rapid. These are the actual exes. So let's grab one of them and take a look at it, and we can get an idea of kind of what's going on here. So user local Lionic. We should just do this. There we go. So we have Rapid right here. So we are going to grab this and bring it over to our desktop. And cool enough, we've got Rapid now. So this is kind of binary analysis, a very high level of it. So what you can actually do with this system here, if you were to grab die, and we open up our wonderful Detected Easy program. Detected Easy is a great software. You can basically dump any sort of, any sort of binary on it, and it'll pick up the signatures on it pretty well. So like if I grab, for instance, like a tar archive, I'm pretty sure it picks that up. Yeah, archive tar. In this case, we'll grab Rapid. We'll throw it on here. We can see that this is a ARM 32-bit executable, so we know the operating system's ARM. And obviously, up here, architecture ARM 32-bit, little endian. We can also see there's a packer, which is UPX. So if anyone's familiar or not familiar with UPX, UPX is something that you can basically take any executable, throw it on there, and UPX will try to compress it and obfuscate it. But it's not. Really, it doesn't try to obfuscate. I shouldn't say that. It's really easy to undo UPX. I'll show you how easy. So UPX completely destroys how the application's normally interpreted here. But what we can do is if we grab our UPX command here, we can see that there is actually an option right here for decompress. So we can just say UPX-D rapid, and I believe -O is the output if I'm not mistaken. Yeah, -O right output to file. So we'll do -O rapid.unpacked. And we can see that we unpacked it. And if we go back, we should, yep, rapid.unpack, we throw it in here. Now we can see that this is a Go program that's been compiled for ARM32. So that's what they're using for this rapid system. You can get into a little bit of analysis. You can rip that program apart. You could alternatively go through and look at all these different scripts. You know, a lot of these are, they got some interesting things in them. Some of this is, I believe, like an endpoint protection software that they use, or these are maybe just signatures for that endpoint protection. But there's a whole bunch of stuff you can go through here that you can dig through and maybe find vulnerabilities on.
How large is this bad boy?
I want to say 250 megs for the full file system, even though it's on a 2 gig chip.
Oh, that one binary right there.
Oh, which one? The Go one?
Yeah.
It is 11.9 megabytes.
You run that?
So
you run that beast through like Joe's Sandbox or anything like that?
I have not done any of that yet. No, I have not.
I'll have some more fun with that a little bit later. Maybe that's a future session we could do.
Yeah, that's very true. As far as securing your hold, I will say right before we end our night, we can see under the process list, we know that the system, because of our logs, is HTTP CGI. We can see this is the user SBIN HTTP CGI executable. What I would honestly recommend if you were going to do any sort of exploitation in that regard of the system in the future, whoops, don't do that. Let's open our directory for user SBIN. And we'll grab HTTP, where is it? HTTP CGI. And this is the main web interface. It's a executable, same as everything else. If we grab our, I don't know if it's, oh, here we go, here it is. We grab this and look at it. It's just a C program. You can actually decompile this in any decompiler and take a look through the functions. If you want to establish a foothold, you would theoretically look through this, find any sort of like a buffer overflow, given that it's a C program, see if you could exploit that at all, see if there's any hidden commands or hidden endpoints that you're not aware of. And then what you could do from there, if you had access to this web interface, you could elevate your privilege through a different method. Or if you could find one of the services that's exposed, because there are services exposed to the WAN on this system, you could grab one of those services as a executable, analyze that. That would probably be your best attack vector, because then if you could get something to that, you know that Shawnee Link uses this, you know their IP space, you know the model they deploy, you know an exploit for that model on all of the interfaces that are public facing. You can just pick all of them up, breach all the systems, get root access to all of them, and then you can start sniffing traffic. You can control DNS servers. You can do pretty much anything on the network level because you are the router. Or you could just DOS attack somebody if you really felt like it. You could do an old Mirai botnet trick.
So everybody, so in conclusion, kind of wrapping this all together, right, from last week into this week here, right, what Dennis has perfectly illustrated is why you and your mom shouldn't be using the router modem wireless access point combo device that's provided by your internet service provider, because it's pretty weak sauce when it comes to the security controls. And Dennis, again, thank you for doing such a fantastic job of demonstrating it and breaking it down. On top of that, I mean, beyond, just that element, we spoke a little bit last week about just a couple of illustrations of internet service providers, like having wireless SSIDs set with pre-shared keys that are just a string of 10 numbers, which is easy for somebody to break into someone's home network, right? And then use those, right? And the internal interfaces as a way to get in as well, right? And you can imagine, like Dennis was noting, that once a malicious actor has access to the router, right, they're able to manipulate everything. And probably one of the fun things that I would highly recommend doing is, if you guys go to do this, wink, wink, nod, nod, right? I don't ever, recommend doing anything that's illicit or anything like that. But it would be really unfortunate for someone to deploy a little DNS poisoning attack that happens to have every web browser that resolves a name entry to load up a little JavaScript file like CoinHive, so that every time someone opens up a web page, it's mining a little bit of Monero for you. You know what I mean? That would be rather unfortunate. By the way, I'm obviously making a joke, but those are actual situations that have occurred, right? People breaking into other people's home networks, right? And deploying DNS poisoning attacks to load JavaScript files into people's web browsers and mine Monero. And when you do it at scale, it actually, it's probably, fairly profitable. So anyways, one of the next sessions that we're going to be hitting on next, kind of follow that is, okay, so how do you build a real secure network, right? So next week, I'm going to be looking at discussing a little bit with OpenSense, pfSense. I'm going to be talking a little bit about Sophos. They use that the UTMs, but I'm going to be more specifically highlighting the XGs. And then I'm going to also speak about what I leverage and utilize, mostly because I'm a noob, which is Ubiquity, right? But it has some nice, digits and or fidgets and doodads, that kind of stuff, and showing you guys how to set up things like, segregated wireless networks, different VLANs, having actual ACLs, setting up intrusion prevention systems, monitoring, country blocking, setting up some honeypots, that kind of stuff, right? So this way, you guys will be able to practice your own life, right? What's really cool is when you're setting things up for yourself and it's your own connectivity to internet, it's a little bit motivating that if you don't have your internet working, it kind of fucking annoys the piss out of you and whatnot. And when you don't get to see your TikTok memes, it really kills your dopamine, right? So you're really, really motivated to learn about networking and security when it's your own home network, right? So we'll get to talk a little bit about that. And then a follow-up to that, probably right after, we'll start talking maybe about like setting up pen test labs, that kind of stuff, that it's beyond the usual like try hack me, hack the box type of stuff, right? Where it's something that's a bit more realistic. Based on my limited experience of what I've seen out there, the labs out there for try hack me and hack the box are fairly limited in really emulating enterprise Windows environments, right? And that's about 90% of enterprises, right? So I think that that's probably a helpful perspective for folks. One of the things I did post in the chat for everybody is a poll. So if you guys could all take a moment, if you haven't already, this is a multi-answer poll, so you feel free to check off as many checkboxes as you want, right? So if you want to have multiple votes, be my guest, no problemo there, right? This is going to help provide guidance to folks like myself and Travis and Dennis on what different topics that we should hit on next, right? And this way we're able to satisfy the greatest demand, right? And also make sure that we're planning in advance, because one of the things that we want to also do in the future is let you guys know, rather than it being like a surprise, this is what's happening this week, right? Setting up an agenda where you guys can expect, hey, this is what's happening next week, and this is what's going to be happening the week after, so on and so forth, right? This way, folks will know when to jump in. People will know when to kind of skip if it's content that they've already are familiar with, that kind of stuff. So to that, any big questions, concerns, thoughts, anything we're missing in regards to what Dennis hit on and the polls and content and that kind of stuff?
These topics in the polls, by the way, are all the majority of them are from you guys' submissions through those end of the session surveys each week. So we are looking at those and reading through those and trying to get as much of the content that's being requested on the roadmap as possible.
Yeah, 100%. No questions? Okay. Well, just a reminder to anyone who is new here or anyone who maybe hasn't been on like some of the previous recent sessions or anything like that. So we're going to be posting the past trainings fairly soon. But if you guys go to the InfoSec coaching and mentoring page, one thing that Travis and myself did is we did remove the direct Microsoft Teams hyperlink, just because if this page gets disseminated amongst friends and colleagues, that kind of stuff, we don't have it getting in the hands of a bad actor. Usually it's a sales guy or something like that then jumps on and says, oh, I know what's going to fix all your problems. This solution, my company's solution. Let's talk about my company's solution. So that's why we removed that there. But if you guys know other folks that are motivated who you believe would enjoy the content and what we're covering and would be able to add to the discussion, feel free to just, forward the invite that Travis and myself have already disseminated. Down here, we have all the previous covered content and topics so far that have had Notion pages created for them. So if you guys aren't familiar with these, certainly go check them out. There's a lot of really good ones there. And then these are some of the different topics we're looking to cover in future sessions. So like I was noting, next session is going to be building a secure home network, covering some of the concepts there, talking a little bit about that. And then we're kind of just blending up some of these other different ones here for different folks on our side who would be kind of leading those activities. Certainly, if you guys have any comments on how we can improve the content here, improve how we're doing the training and all that kind of stuff, please do not hesitate to let us know. And then let's do this. Before we open it to like a general open forum, which, maybe somebody wants to pick like Dennis's brain or my brain or Travis's brain, we'll all just kind of hit on the feedback survey, and then folks who
That's
are
a real quick question. I know a few people I've shared the link to recently. I've just shared the Notion link. They don't actually have the direct meeting link. So if that's you, reach out to me on LinkedIn again. I'll send you the actual link, or just shoot me an email. I put my email right in the chat, and I'll add you directly to the meeting link. Just let me know whatever email address you want it to be sent to.
Yeah, great. No, thank you. So with that team, again, if you guys could take a moment to fill this in here, provide some feedback, most particularly for Dennis. Dennis, you did an absolutely awesome job yet again tonight. So thank you for all your hard work, because obviously what you did is not something that's compactable into, like, you didn't do this in 1 hour or 2 hours, right? You spent, it sounds like, at least 15 hours in totality, and then also took the time to then really structure it well for everybody else so that we could follow along. So again, that hard work is really, really appreciated.
Sure, thank you.
What we'll do, we'll open it up to everyone else. Open discussion. Is there any general questions, concerns, thoughts, any topics you guys want to pick our brains on? Any fun, any recent items in the news or anything like that? So Manchester, if you have the meeting link already, it's the same meeting every single week, right? So no worries, man. Yeah, so you can just always use that same meeting link. It doesn't change.
I just want to say, Dennis, I was feeling a little lost last week when you were first going over this. But as you kind of finished this week, I just want to say it was a lot easier for me personally to follow. And I thought it was really well structured. And I thank you for the demonstration of the actual real life hands-on, pen testing, hacking, reverse engineering kind of stuff. I loved it.
Well, I appreciate that. I will say, yeah, it's definitely it is very hard to take something that was done over, as Christian said, I'd say 15 hours is probably about fair. It's very hard to take something like that and compress it down. I hope it was. I know last week was a little rough because we were getting into it, and it was just like, where was the end goal? But now that we've got there, I'm glad that I'm glad it all came together. That was my big concern, but it sounds like it all worked out in the end. So I appreciate that feedback.
Absolutely.
Cool.
It spurs an interesting conversation for the future when you think about how much time and how far Dennis was able to get hammering away at this one system. When we do internal pen tests, sometimes we have 5/8s the customer gives us, and you have so many things that you want to look at trying to figure out where can you afford to spend the time, because you've only got a very fixed amount of time to do it, and that shows the difference between a penetration test versus a malicious actor who can sit around for 10 months trying to break into something slowly and methodically. And we got to balance running through it like an angry pirate with also being a ninja at the same time.
Yeah, the other problem that you can run into with, for sure, is scope of what's allowed, rules of engagement. For instance, if this was an actual, say, customer system, given the functionality we tested, I don't think there was anything destructive that was done per se. but there definitely is, in some cases, things that could be disruptive. For instance, if there was file uploads that would affect business logic, if there were anything of that capacity that could affect any sort of production data, most instances you want to have it for UAT or stage environment when a customer comes to you. But in some cases, some cases they don't have that option. Some cases you have to give an analysis of a production environment, and in that case you have to walk carefully. So sometimes, as tempting as it is to try and replace the etc shadow file on a system, you're going to ruin some poor sysadmin's day.
I know
And
that,
Christians when they get angry at him.
Oh yeah.
gentlemen, I know that pain too well. When I was a wee junior pen tester, I was contracted by an internet service provider to do pen testing. They gave me all the stuff that's like, yeah, just tell me the infrastructure it's in scope. And I like got all the stuff that's that I like added it up, and I was like, it's like 1.2 million fucking IP addresses, dude. This is all like, are you sure this is like actually in scope and whatnot? And they're like, yeah. And it was like a new global, like, it was the new global chief information security officer, right? Who had no fucking clue of what was happening with all the subsidiaries and all those IP addresses, right? So when we started the pen testing, and like I found like an easy like edge switch I was able to break into, and I like broke into it, and I was like, wait, this doesn't have your business's name on it. This has another business's name on it. And I was like, this is one of your customers, you asshole. So those things actually happen. Now, luckily, I didn't set it on fire or anything like that. But then after that, once I had seen that, right, basically I had to write a bunch of Shodan scraping scripts and all that kind of shit that would pull all the banners and fingerprint the systems. And then I had to like, okay, based on the host name, it looks like it's actually owned by this internet service provider versus one of their customers, that kind of stuff. And then kind of gauge my risk in breaking into it, And then like Travis was noting, at scale, right? The objective of a pen test is not to find every particular or every vulnerability and weakness, right? It's to find the most severe vulnerability and weaknesses and exploit those, gain a foothold into the systems, right? Complete a kill chain, right? All the way through lateral movement and persistence, doing some type of simulation of like exfil or whatever like monetizable, attack process is occurring, right? And then demonstrate that to a customer and give them the, roadmap on how to cover those like massive gaps, right? But when it was something that was like, like 1.2 or 1.3 million IP addresses, that was a bit of a toughie.
We had one of those in Q1 this year, and it took like 6 days to run the Nmap script on the whole scope. It was outrageous.
Yeah, and it was a lean one that you created there too, right?
It was lean and fast.
Specific ports and that type of shit. Yeah.
Yeah. The other thing to be noted as well, actually, while you were talking about that, that reminded me, we did talk about getting the original etc shadow file. So obviously in replacing the etc shadow file, you've lost what the original root password was, and you've lost the potential for brute force. There's actually a ROM folder on the system, which is a map to read-only version of the file system. The ROM shadow file has nothing. The root has no passwords. So I guess the ISP sets them, is my current guess. In this case, we still lost it, but it's not set by the manufacturer at least. So that's an upside.
Interesting. One of the things I would suggest next with that binary, you said that it was what was the name of it? Rapid.
Correct. Lionic Rapid. Yeah.
Yeah. And you said it looked like some antivirus, but also like malware.
No, it is an antivirus. It is it's marketed as an antivirus. I personally don't trust it because it's something that I can't disable, and it's something I can't inspect, and it's running constantly on my system, and it's monitoring all the network traffic. Now, if you want to trust Calyx, are they doing anything malicious with it? Probably legally the answer is no, but at the same time I don't trust it.
So what you should do, so you can make a free Joe Sandbox, you can make a free account, right? Upload Linux binaries, right? And what it'll do is it'll actually do dynamic analysis of the binary. It'll run it in a sandbox for you, right? And it'll tell you what various like IP addresses and DNS entries it's communicating outbound to, right? What it's trying to touch on file system, all that kind of stuff, right? And it'll break that down really, really thorough and effectively for you. And then it'll give you a hex map of all that too.
You can actually see, because the only packer that they have on this, if I remember, is UPX. You can actually dump strings as well and get some of that information. And given that it's a Go executable, Yeah, a lot of that's just out in plain text. I know that you could potentially reverse engineer it easily as well. Go makes it a little bit harder because it's, they throw in their helper methods in there. But for the most part, you can dump the strings, get a pretty good idea of how it's running. But yeah, I will keep that in mind, try out Joe Sandbox and see what it does.
Cool. Excellent. That is some super interesting sus shit you found. So I guess that's another reason for everybody to not trust the service provider. So to that team, any last items before we jump off here? Concerns, thoughts? No? Okay, super. Well then, everybody, thank you so much for your time. Really appreciate it. Dennis, thank you so much again for an excellent presentation. It was really entertaining and it was also really engaging and insightful. Hope everyone has a good one. Bye now.
Take care.
So guys, take care.